Hello, it's Andrew, and this is going to be my reflection for Year 2, Cycle 4. We did a basketball analysis. So when I introduced the project using No Basketball to talk about the video that they have where you want to have a 45-degree entry angle, I was surprised to learn that many students didn't actually want to do the activity. It was a very hard start. There are a few students that said that they already dropped off the basketball team unknown to me, and it made it really hard to get them into the lesson at the very beginning. I wanted to maybe end with this activity after thinking it more in depth, but the time that I wanted to go out on the basketball court was actually being used, so I ended up going with will it hit the hoop at the very beginning. And because it was such a hard start, this was also a really hard sell for the students. You can see the results. The left-hand dot represents the student's individual guess for just eyeballing whether or not it would go in the hoop, and then on the right hand side this was their guess, or not their guess, but they're using their parabola to figure out if it would go inside the hoop. And you can see in almost every case the student eyeballed it better than they could use the parabola. The reason for this being they didn't spend enough time to actually play with the parabola to make sure that it would go in. And some of these were hard because bank shots they didn't really predict. So for the outcomes and impacts of this project, the biggest impact was students getting more familiar with video editing. And that wasn't exactly what I was going for, but I'm glad that they have this skill now. This was an example video that I did to show you how many things there are that they had to do. So they had their normal video of them shooting the ball that they had to cut to size, and then they also had this video tracking part of the video that they had to do. And this just requires a lot of shapes that have to be put exactly on that arc, which requires a lot of pausing and playing. And then they had to do a video analysis analyzing what they did, and then ending with a screenshot. So in terms of the video editing, there was a lot that I didn't really expect them to have to do, and they did learn how to use the software fairly well. The other thing that they learned how to do well was using Desmos. So this is the Desmos project that we worked on. And you can see that they have their picture that they screenshotted after they edited it with the video editor. They have their equation of the parabola. They learned how to do bounds for their parabola to cut it off so it doesn't go from negative infinity to positive infinity. How to play around with these variables, how to set bounds on the variables, that way they can get it more precise. They learned how to make something on an arc. You can see that this tracks the arc instead of just going all over the place. And then the final part was the calculus part. And they basically just kind of retyped this, and I explained what everything did. I told them that this f prime of d, that was a calculus term that meant that it was the slope of every line. And they could accept that that was the slope, but they didn't really understand where it came from, and I didn't want to spend the time explaining it to them. But they did appreciate that they had less work to do because of calculus. And then the trigonometry term down here, using arctan. I could have explained this more, but we haven't really done a lot of trigonometry review from geometry. And I kind of just skipped this, and they also retyped this in just to find what angle it's at any point. And you can see when I drag the ball, just like on their count, you can see that this is the angle at any point for the entry angle. So if they dragged it right in the hoop, their entry angle would have been, well, mine was 43.8, which is pretty close to 45. And the third thing that they took away from this lesson was an appreciation for how mathematics could be applied to the real world. Again, it started with a really tough sell on the previous day, but after they saw, like, wow, it's actually a parabola, and it's a perfect parabola if I made all my points perfect, and using some math, I can figure out the angle. They thought that it was really cool that you could find the angle, but I couldn't get them sold on how this could be applicable to improving their shots. By the end of the day, they did say, okay, well, I know that I need more arc or less arc, but they also commented that they could probably just see that just by taking a video without doing the mathematical analysis. But they definitely thought that it was pretty cool that this did apply to the real world that they had never seen before. So the next steps after doing this PBL is to continue on with the lesson. Again, we stopped kind of halfway through our unit to do this fun PBL. And while going through the unit, we're going to be solving some quadratics, and I'll be able to relate that back to our problem. So I can say, well, remember when we did our basketball shooting, when we're trying to find the zeros of a quadratic, that zeros would have been where the basketball would have landed if it didn't hit the hoop. So you can kind of picture this arc. If it came down into the x-axis, where would it have hit? So I'll be able to refer back to that real example, and maybe talk about some other elements of our activity in order to make it more concrete in their minds instead of just an abstract concept finding roots of a polynomial. I have no idea what I'm doing, but after doing this project now, they should know what they're doing. And that was my Cycle 4 reflection. So thank you for watching, and I'll see you in Cycle 5.